At Carvana, we're in the business of driving you happy. And with the widest selection of used cars under $20,000, you're bound to find a car that'll put a smile on your face. Carvana gives you control by letting you customize your down and monthly payments. You can browse tens of thousands of cars online to find one within your budget, and you won't get surprised with any bogus fees. Visit Carvana.com or download the app to shop for a vehicle. Carvana, we'll drive you happy. Availability may vary by market.
Hi, this is Martin Fowler, and you're listening to the Agile Uprising.
Greetings and welcome to another edition of the Agile Uprising podcast. I'm your host, Hrcsko. Joining me once again, my frequent collaborator, partner in crime, fellow New Jersey native, Troy Lightfoot. Troy, how are you?
I am wonderful. I am glad to be here to talk about this topic.
All right. I am stoked to have you here. I have no idea where it's going to go, but we're going to go there. So, folks, this is another unscripted episode, and this comes out of Troy and I have been bouncing around we've had a long-running conversation. I think we're up to like 6 or 7 years now, about things like predictability, the ability to deliver, Don Reinertson, Little's Law, theory of constraints. Troy and I have had a long-running conversation going back and forth. And what we wanted to sit down is to actually put some of these thoughts to paper, because the last episode that Troy and I did is one of our most listened to episodes, and it was really him and I off the cuff talking about how to use the principles of the manifesto as metrics.
Yep.
Believe it or not, it's one of our most downloaded episodes.
Should still do it, by the way. If you're listening, go back and listen to that episode and do that, actually. So, yeah.
Put the link in the show notes. So Troy, this conversation came out of you're an instructor with Pro Kanban, and you teach the course Applied Metrics for Predictability. And you and I went down the rabbit hole because we were talking about not just where we get it wrong, and I mean we in the royal we of practitioners, coaches, etc. But we have propagated bad ideas, or maybe not bad is probably the wrong word. We have propagated not fully formed understanding, right? And I'll start with I'll give you a cue, and I'll start with we were just talking about before we started recording Don Reinertson and the principles of product development flow, where I'm actually reading through it. Embarrassingly, I've never read it before. And I'm about halfway through, and I've realized that we as Agilists kind of got some shit wrong. We misinterpreted, misread, translated it in a way that there's some real brilliance in it that we kind of missed out on. And I'm not trying to talk crap about us, because, shame on me. And we've been doing this show 7 years. It's the first time I ever read the book, mea culpa. But we did kind of screw up the translation, didn't we?
Oh, big time. And now, and I'm going to go one step further. Not only have we misunderstood certain things, we've also, and I'm putting myself in the same category, so I'm not blaming anyone. You can only blame yourself. But we've also utilized practices and promoted practices which are at best bad, at worst extremely harmful to not only the people we coach, but to ourselves as practitioners and as even an industry, if you want to call it that. And so maybe we could talk a little bit about that today.
Yeah. I want to go in on that, right? And we talked about, so to give a little background, Troy and I have been sharing in our long going conversation the importance of going back to the beginning and going back to the stuff that is the cornerstone stuff that is the bedrock of what we practice, right? So Troy and I were talking about John Little's paper on Little's Law. We were talking about Reinertson. We were talking about Frederick Taylor's work on scientific management, and how we really do need to go back to understand through our own eyes, through our own lens, what these things were, what they were trying to do. So Troy, what have we screwed up? Where have we? So I'm sorry. Screwed up is a strong term. Where have we gone astray? That's a better way to put it. Where have we gone astray?
Well, good question. Actually, before I answer that question, because there's a few things, and it's an opinion. Obviously, this is just an opinion, so take it for what it's worth. But my hope is that through this conversation, people might at least understand why I and others might have the opinion, not necessarily that you have to agree with it, of course. Okay, so how this podcast idea first started was I built an Excel calculator. Okay. And this Excel calculator is about right-sizing features and epics. How do we know that a feature or an epic is a quote-unquote right size? Like, how do we know it's small enough to bring into our process to not blow it up, right? Because the truth is, we don't know actually how big something is really until we've delivered it, okay?
Right.
We can think we do, right? But until we've delivered it, then we actually know how big it was in a sense, right? Before that, we're simply pretty much just guessing, okay? So that's one thing. The second part is you can apply that same thought, same concept to value as well. So there is, in the Agile space, there's a lot of frameworks, techniques, practices, time spent figuring out how to best prioritize work, right? How do you find out the value of something before you deliver it? Because obviously, how are you going to prioritize your product backlog properly, right? And now this lends itself to hours and hours and weeks of time trying to figure out what the value of things are, trying to estimate that value, trying to forecast the value, and then on top of that, trying to estimate and forecast the size of things, and then trying to figure out how to order the backlog. And then it lends itself to a lot of time and effort spent on a very large backlog, and not saying everyone does this, that may or may not all be built anyway, right? And so
we're basically daisy chaining assumptions, right? Because back to our conversation about the frame that we view things. Value is not objective; it is subjective. Effort could be subjective, right? Tying these things together, I think this is not valuable, but it'll take 3 weeks. You think it's super valuable, and it takes 2 months. So I think that part of what you're talking about is trying to remove that vagary, right? Remove that subjectiveness and try to put its paces through an objective lens.
Right. So the question is something like cost of delay. Let's start there. So the Agile community, when they say, and I'm being generic because not everyone means this, of course, but at least from what I've seen, when they think about cost of delay, a lot of people are equating it to the safe way of thinking about cost of delay, right? They're thinking about combining a series of Fibonacci numbers on business value, time and criticality, and risk reduction, opportunity enablement, and then dividing it by another series of Fibonacci numbers around a job size, okay? And then using those, and by the way, the Fibonacci numbers are all estimates, right? Doing that estimation, dividing it by another estimation, and then thinking that that is sequencing by an maximum economic, delivery, right? How you sequence that work, right? Okay. So that's kind of how most people in the industry, in our world, think about cost of delay. And if you read Dan Reinerson, that is not at all what he means by cost of delay. This is not an episode on cost of delay. It's more about, he talks about that in order to understand cost of delay, you have to actually understand what the total lifetime value of a product actually is. And then you have to calculate the curve, okay, the lifetime value curve. And then this is some math to it. But basically, we could do a whole episode on this if you want, but without going too into it, the cost of delay is actually the rate of change in the curve, essentially, the derivative of time and money, okay? That's what he says. Now, if you know exactly what the lifetime value of something you're going to build is, if you actually know it, not an estimate, not a guess, if you actually know it, then you could calculate it, right? And there might be instances where you might know. For example, if you know that there's some regulatory change coming up, and if you don't make it, it's going to cost you $1 million, right? Okay. Then technically, you might be able to calculate the actual quantifiable cost of delay over time, right? But for the type of work we typically do, product development in this space, right? There's no way that you can actually calculate the cost of delay of something. It's just impossible because that's assuming that you know what the future is going to be.
Right. And again, software is ephemeral. It can be stood up and blown away at a moment's notice. And there is no guarantee because it's theoretically, it's not supposed to live forever. So it's not like where you buy a car and you could say, okay, well, I think the frame is the example you used, Troy, in a training class, God, this had to be 5 years ago, which still rattles around in my head. The cost of delay for the Apple AirPods.
Yeah.
They figured out, this is hardware. How long will this change take? What's the cost of delaying this and not getting to market? And that's an easy example. Software, gets very, very tricky.
Yeah. So good point. So, by the way, there's nothing inherently wrong with having a conversation about business value, time, and criticality. There's nothing wrong with that. It's just that when we equate that with what the actual cost of delay is to something like quantifiable and use it as a way of saying this is what it is, it's just not true. I mean, but that's okay to have the conversation. And if you think that conversation is helping you sequence your backlog, by all means, right? That's fine.
Right.
So, but I have something to show you. Okay, and this gets me to my. Before I show you this, I have a question for you, Jay. In your opinion, you didn't even know I was going to ask you this, so I'm inputting you on the spot, but it's an easy question. Why was Agile? Why did the 17 Agile Manifesto authors get together in Snowbird, Utah, right, and create the Agile Manifesto?
If I remember my history correctly,
yes.
It was an unhappiness with the way that software was being developed and delivered in the world at large. The big upfront design, the traditional, we'll call it waterfall critical path method, was not responsive to change, too slow feedback loops. And I vaguely remember the remark that they felt like they spent a lot of time building shit that people were either wouldn't use, wouldn't need, or wouldn't work.
Right. Thank you. You summarized it beautifully, by the way. So I couldn't have said it any better myself. In fact, I probably would have said it worse. So I'm going to try to summarize what you said in the way I think about it, right? There was a reaction to people thinking that they can know exactly what was going to happen in the future. Like a deterministic approach to product development, which is if we just plan enough, if we just write the requirements enough, right? If we just do well enough, if we just do all of these things, if we just do QA enough where we find all the bugs, right? We just do all this stuff. By the end of that, we'll be able to exactly hit the budget, the time, the scope, everything. And it will work too. Like people will like it, right? Because we did all this planning and all this upfront analysis, right? That is a deterministic way of thinking. Meaning you think that you're acting as if there's only one possible outcome. And so all of the waterfall style of practices are based on that type of way of thinking. That's why they try to lock in everything, right?
Right. If we could only get better at estimating, Troy, our projects wouldn't slip.
Right. So that's one, So that's one aspect of it, is the delivery piece of it, like the timing piece of delivery. There's also the aspect of, hey, we want to release something 2 years from now. Let's spend 6 months planning and doing analysis and figuring out exactly what we should build, because that's what will work. And then we'll spend millions of dollars going to do that. And then when we release it, of course it's going to work, because how could it not? Because we're the smartest people and have all this money to do it, right? And then you do it, and sometimes it works. More often than not, it doesn't, right? I mean, that's just pretty much how the world works. So the Agile is kind of a reaction to that and saying, look, we don't know what the future is going to be, right? So how would we what kind of processes, what kind of techniques and practices can we use to work more with an empirical approach, which assumes that we don't know the future, right? And how can we learn faster to find out if we're building the right things or not and the right way? That's kind of the whole Agile way of working, right? Unfortunately, that has not, in the Agile community, a lot of our practices on paper say that, but in reality don't do that. And one of them actually is the way that we prioritize work. How many times, Jay, have you seen people do a quote unquote Agile project, which is basically a fixed scope project, where they pretty much think they know exactly what's going to happen. They write out 1 billion user stories, right? And then they put together a release plan over a year, 18 months, and then they try to hit those dates. And then they blame Agile and Scrum when they don't hit the dates and the whole thing. They're basically just doing waterfall with some Agile practice.
Right. I have lost count of the amount of time.
That's pretty common. So that is not obviously what the Agile Manifesto authors were thinking about, right? So that's one thing. The second part is, even Best case scenario, we don't do all of that, and we try to work in an empirical manner. A lot of the practices that we use are deterministic practices, meaning we can forecast using averages, using relative estimation, that something is going to be done in 8 sprints or whatever the case, right? That type of answer of when will it be done or how many things could be get done by a certain date is always given with a deterministic answer. It's going to be done on December 21st. It's going to be done in 8 sprints. It's going to be done between 6 and 8 sprints. It's still a deterministic answer, actually. It's still assuming that you know what's going to happen in the future to be able to do that. So it's the same concept as the upfront thinking that you know what's going to happen in the future with the value concept. So what we're saying from Pro Kanban, because as you mentioned, I'm a Pro Kanban trainer, I'm throwing myself in and say we, because I've been doing a lot of trainings for the last few years, is let's assume that we don't know what's going to happen in the future. That's kind of the whole reason Agile exists in the first place. How do we have to act when it comes to value? And how do we have to act? What should we do when it comes to delivery? Both of those things, assuming we don't know what's going to happen. So there's the first kind of thing I wanted to talk about is deterministic versus probabilistic thinking. So probabilistic thinking, all it really means is that you, whenever there's more than one possible outcome to something that could happen, then you would think probabilistically, that there's not one possible solution. There's not one possible answer to it. And you have to think differently. Basically, that's really all it means. It's pretty simple that way. The very basic, most common scenario is the weather, right? So for example, you look at your app and it says there's a 60% chance of raining at 3 p.m. That is not a deterministic forecast. That's a probabilistic forecast, because there's a 40% chance it might not happen. There's a 60% chance. That's a probabilistic forecast. And there's why, let me ask you this. Why can't they say with 100% certainty what's going to happen?
Oh, because the system is entirely too complex to model all the attributes reliably with a tolerance of variability that is so low that you can realistically say the butterfly flap its wings in Japan. We're gonna get the hurricane in San Francisco, right? It's way too many attributes to model. Yeah.
And so probabilistic forecasting is used heavily in weather, but it's also used to save lives in weather. For example, for hurricanes, it's extremely critical that they continuously update their forecast using probabilistic forecasting. That actually is how they try to save. And they, in fact, one of the things we talk about in the AMP class is Hurricane Sandy. We talk about at the beginning using a case study about how they actually saved thousands of lives using probabilistic forecasting, actually, and we go through how it did that. So that's one thing. Other industries use it all the time. So for example, in finance, probabilistic forecasting is used for your 401k, for your portfolio, for your stocks, for your portfolio. They don't think deterministically. Because they know that the future is uncertain. So they have to use probabilities. They have to think that way. The same with machine learning. You know, the whole concept that AI is the new hot rod. AI is the new crypto, right? Where it's like everything has to be AI. Crypto, what it was 2 years ago with the blockchain, right? Oh, everything wanted by the blockchain. Now every single product has to have some kind of AI to it, right? But the way that is built is using probabilistic forecasting. It's like they build these models based on probabilities. Okay.
Right. So it's predictive typing in Google. They're using a probability to say,
yes,
okay, realistically, Troy is probably going to want to use these terms next based upon what we know about English and Troy's emails and so on and so forth.
So if you think about the industries we're talking about, right? And there's more than this, by the way, but if you think about finance, machine learning, right? Weather, saving lives, all these things which are heavily impact people, especially finance, right? And weather, right? Heavily impact people's lives, their futures and things like that. They are not giving a deterministic answer. They're using this way of thinking. So let's talk about, I'll show you an example of that in a minute. But so for those at home, if you're bored already, follow along because I'm going to show you some pictures and maybe pictures will help. Okay. So let's go. Let me share my screen. I'm going to play a little game with you. Okay. Get ready for a game. This game is called Gambler's Ruin. Okay. So now this game comes from a guy named Pratik Singh, who is one of the co-founders of ProKanban.org. Actually, this is his game he built. Okay, so I'm going to play this game with you, Jay, and hopefully we'll get to my Excel calculator coming from this game. Okay, so why I created it in the way I did. So all right, so we have a game. You can see my screen, right?
Yep.
Okay, so the game is called Gambler's Ruin. Basically, I'm going to summarize this. There's two players playing against each other, okay? They have a starting bankroll of $1,000. Neither one has an advantage over the other one's skill. They're at the exact same skill, okay? And the size of the bet they're going to make initially is $500, okay? So what do you think? Now, the way the game works is these people are playing some kind of gambling game. It doesn't really matter what it is, but they're placing a $500 bet, right? What happens is whoever loses that has to hand over their $500 to the other person. Now the other person has $1,500. Then they play another round. Whoever loses that has to hand over $500. So the game ends when somebody's
out of money. Okay.
Right. Okay. So what do you think the odds of player one winning are?
A 50-50 if there's no advantage.
Okay.
Right?
Okay. So let's do this. We'll play a round, and you can see the round happening here. Okay. Mm-hmm. Play another round. And it took 4 rounds, but player one won. Now, you can play the game again. I'll play it again, right? You are correct that it's a 50-50. Now, you will notice that each round, the round numbers are changing, basically. At home, you won't see this because I'm going to take a single shot. But basically, every time we run this game, that's a different amount of rounds. Okay, now that's actually an important point. Now, I'm going to change this to a full game. Okay, now I'm changing. Now you know that in the first scenario, it was a 50-50, basically. Okay, does that mean, let me ask you this, Jay. If I ran this game and player one, you've never seen the game before. Player one won the game 3 times in a row. The first time I played it, player one is 3-0 versus player two. And I asked you to forecast, to make a bet about which player is going to win the next round. Who would you bet on and why?
This is that whole coin flip thing where I know I'm going to make myself feel stupid. Don't
worry about it. Just this question.
So again, if we're equally matched and I've won 3 rounds, history doesn't really mean anything. We're equally matched. So fuck.
Well, don't stop. I'm going to stop you there before you say something incorrect, because what you just said was correct. So the lesson, what you realize while it seems very obvious that it's a 50-50, the more the data starts to realize itself in front of our face as human beings, we start to notice patterns in the data as human beings, right? And the patterns are a lie. It's one of the big kind of lessons about this whole concept of probabilistic forecasting. That just like a roulette wheel, right? People go to roulette, the wheel is spinning, black, red, green, blah, 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 right? People are looking at that computer screen, and it's showing them all the results. And they're identifying, oh, well, there's 9 blacks and there's 2 reds, so therefore it's red is due, right? Or obviously black is more likely to hit, right? The odds of black or red are exactly the same every single roll. Okay, it never changes. So this is something called the gambler's fallacy, where you use previous data to forecast your bet on, even though the odds are not different. Basically, that's the gambler's fallacy. Now, reason why is human beings are not good. We're really good at pattern recognition, but that actually is a bad thing when it comes to financing gambling. Okay? So, because our pattern recognition gets us in trouble because we don't have the full set of data. So there's something called the law of large numbers. And the summary, I might butcher this, but the summary of the law of large numbers is that the closer you get to infinity, the closer you get to the actual answer. Okay. So if you could think about a roulette table. A roulette table has red, black, and green. The original roulette tables only had red and black. Okay.
Okay.
Now, red and black, if you only had red and black, that is a true 50-50, right? The reason they add green is to weight the odds in the casino's favor. Okay. Now, what happens is if I were to roll that roulette wheel and bet on red 9 times in a row, right? And I won 9 times in a row. Okay. And then I were to say, well, I know what I'm doing now because I figured out the pattern, right? There's a pattern here. I'm going to bet all my winnings on red now or black because maybe it's due, one or the other. the odds of coming up red are the same no matter how many times it has rolled the same in the past. And though how you would know that, or the only way you would know that actually, is to spin the roulette wheel millions of times. If you spun the roulette wheel millions of times, you would actually see what the actual chance of, like you would just calculate it, you would just record everyone, right? You will see what the actual probability of red or black is, but you can't see it without a very, very large data set, basically, okay? So that's one thing to think about. That we'll be talking about that and when we get to probabilistic forecasting. The second part of Gambler's Rule, though, I want to show you because I want to get to my Excel sheet, is this. Now, I have changed the game for you, okay? And I'm going to apply the law of large numbers to this game now, which I haven't done in the past as I set this up. Player 1 has $1,000 starting bankroll. Player 2 has $10,000. But player 1 has 10% more skill. Now, and the bet size is 500. Who do you think is going to win?
I'm going to, I don't know if it's cheating, but I'm going to guess.
Yeah.
I kind of think player 2.
Okay.
There's a part of my gut that says player 2, and here's why. He's starting from player 2 is starting from a much more advantageous position because they have a much larger bank, so they can afford to lose more.
Right.
And I'm thinking of in an infinite amount of coin flips, right? If the heads is +1 and the tails is -1, you don't stay within the mean. At some point, it's going to diverge and go wildly in the other direction.
Okay.
So I'm going to guess player 2.
So here's what we're going to do. We're going to play the games now. We're going to run a bunch of simulations, okay, in the background, and we'll see how many times player 1 wins versus player 2, right? You're applying the law of large numbers. Okay. So it's not that large, but it's only 1,000 simulations, but it's good enough for this game, okay? So player 1 wins 33% of the time, and player 2 wins 54% of the time, okay? Actually, no, not 54. Excuse me. It would be what? 66.4% of the time. Okay. So I'm going to run it again. It's almost the same result. I'm going to run it again. It's close to the same result. You can see. Now, if I were to play this 1,000,000 times, it would almost be the exact same result every time. Okay. That's applying the large and large numbers. The closer you get to infinity, the more you get to the actual probability of something happening. Okay. So number one, the player 1, right, has a skill advantage, yet they keep losing. Okay. So now if they only had 1% skill advantage, what do you think is going to happen? Let's run it again.
I still think player 2 wins.
Yeah, big time. Right. Like way more, right? So you can see there is value at getting better at something, right? For sure. And in our world in software development, right, what's getting better mean? It's all of our agile practices, being able to applying flow, like
predictable,
right? Automation, DevOps, all of that stuff is your competitive advantage, right? It's why we, as coaches and consultants, that's why we have jobs, because people want to get better at something, right? So to me, I look at this number as, oh, this is us making an impact, right? This scalar, basically, right?
Right.
Now, but this company only has $1,000. Now, if I gave this advantage to the second company, player 2, they would just crush player 1.
Oh, they would destroy player 1 much faster than they normally do, much more frequently than they do. Yeah.
Now, what if I change the size of the bet to 100 instead of 500? What do you think will happen in this same scenario?
So player 1 still has an advantage, but the bet size goes down.
Only 10% advantage.
Yeah. But I'm still going to go with player 2.
Okay. Okay. All right. Now it gets interesting.
Again, even in a $100 bet, that's 100 bets that player 2 can make versus the 10 that player 1 can make. So, go for it.
You said it out loud. With a 10% advantage, right? Player 2 can make 100 more bets, technically, right?
Right.
Okay. They have 10 times more money than player 1. Now let's see what happens.
Oh, wow.
Okay.
Wow, shit.
All right. So
obviously I was wildly wrong.
Okay, so for those who are not looking, the numbers are coming up that player one has an 85% chance of winning with a bet size of 100, with only a 10% skill advantage. Now let's back the skill advantage down to 5. Even with only a 5% skill advantage, they have about a 66% chance of winning, okay? All we did was change the size of the bet. That's it. That's all we did, okay? Now, most people think about what's the most important thing you can do in Agile and product development, right? All of these things. Changing this from a value perspective, going back to the whole idea of trying to quantify the cost delay ahead of time, which is pretty much impossible in our world unless you have a very specific case that I gave you earlier. We have to think in terms of bets. So there's a book called, her name is...
Thinking in Bets by Annie Duke. Yeah.
Yes, Annie Duke, yes. I was trying to think of her last name. Thinking in Bets, right? Basically, we have to think about every investment that we make, right? Every new project or product idea, every new epic or feature or planning to spend money on, right? Don't assume that you know what the value of that is going to be, okay? Assume that you don't. And place the smallest bet possible financially to go find out if you're right or wrong, right? It's the whole concept of an MVP, an actual MVP, not what people think a lot of people think an MVP is, okay?
Right. Peter Merrill calls it riskiest assumption. Test your riskiest assumption first.
Now, I'm going to link a video, by the way, to a Drunk Agile YouTube video, where Pratik actually goes over different scenarios that he's running using probabilities, and where he shows different prioritization techniques, like, for example, cost of delay, only by value, only by going, well, whatever the smallest size is, pure random. And he goes over like different scenarios, right? And all of that. What it turns out is the gist of his talk, really, is that at the end of the day, the way to maximize your economic value is by prioritizing by smallest size. That's actually what it shows mathematically. And this is what, yes.
I don't want to lose that thought, right?
Yes.
But I want to go back to the math behind this game, right?
Yes.
So like you said, we took the player's advantage down, we took the size of the bet down, and yet exponentially player one wins more, right? With the size of the smaller bet. What is the logic behind that, Troy, that I don't understand?
There's math going on in the background, by the way, that I will link you to because it is much more complex than I can just share here. And I'm not even pretending that I fully understand the math because I haven't really looked into it. The point is, when you're working in probabilities, you don't need to do the math. All you have to do is play the games 1,000,000 times.
Gotcha. And I was just, and this is morbid.
In this case, 1,000 times. But basically, if you simulate something enough times, the actual probability will reveal itself.
Right.
So there is a mathematical calculation to given the advantage here is what's happening on the background. Okay. And then
I'm just trying to figure out where my mental model was wrong. Right. Like what, because I want to thank you for helping me embarrass myself in front of the thousands of listeners.
It's okay.
Thanks, Troy. I was really looking forward to this today.
Now I'm going to change it to, I'm going to change the size of the bet to 50. Now, note that player 2 has 10 times more money. Okay. 10 times more money.
I still think player 1 wins.
99% of the time. Okay. With 10 times more money, you lose 99% of the time if player 1 has an advantage over you, even only 10%, okay? Competitive advantage, whatever that means in our world, right? And you work in very small sizes. The bets you're making to the market are small. If you can think about how to break work as small as possible while retaining enough value for you to be able to place a bet, that is the key. Like you have to be able to see if you're going to make value from it. It can't just be so small that there's no value at all to it, right? It has to have some type of value to it. So you can think about like when you're developing a new product idea, right? What's the smallest bet you can make? And the bet should be based on your assumptions. So like, for example, we assume that if we deliver this product based on all our research and all of our analysis, that we're going to see these business benefits and the users are going to see these benefits and they're going to use the hell out of the product and they're going to love it. Okay, these are a bunch of assumptions. Pick the riskiest one that if you're wrong about, you're going to lose all your money. You're going to ruin yourself, right? Go place the smallest bet and just keep doing that with very small bets and trying to win, right? And you don't have to have a lot of money to do that, right? And that's where like small companies that don't have a lot of money, startups that are just starting out, they work this way, right? They don't have all of the bureaucracy. They don't have to follow all the old school practices, and they don't have to spend $100 million or $20 million before something is released, right? They will work in small bets with a competitive advantage. That's exactly what they're doing, right? So that's the kind of lesson here. So the calculator I built is basically a way of helping you think about how to do this with features in Epic. That's what the calculator is, okay? Without using story points or doing a ton of upfront estimation, okay?
Right.
So that's really what it is. I want to show you one more thing, which you may find really fascinating, Jay, before I show you this calculator. So the thing I want to show you is another thing. This guy Pratik, I love this guy Pratik. If you ever get to meet him, he's awesome. Or even just get to talk to him online. He is, again, he's like co-founder with Dan Vacanti at ProConbon and Colleen. So he ran these simulations. Now, this is talking about really the idea that we should spend so much time prioritizing our work that the prioritization technique matters all of that much, right? What we're trying to say is it really doesn't. If you can place small bets, if you can break things down into small sizes, which has some type of value, and the second part of that is you can actively control the amount of these bets that you're placing at a time, you will set yourself up for success far more than any type of prioritization will give you, because we don't know the future. So in this example, what I want to show you, this is based off of a real team, by the way, but some of it is real, some of it's like made up for a simulation, okay? So what you're looking at here, you can see my this Monte Carlo document here, what this is. Okay. So what you're looking at here is I think this is 18 features, right? Where someone has spent a lot of time figuring out the priority of these features, okay? And a team, this is what's in this team's backlog, all these 18 features. And you're trying to figure out, okay, if we have a certain date we're trying to hit, right? What is the probability of these features being delivered by a specific date? It doesn't really matter what the date is in this scenario, okay? Maybe let's say the next 30 days, 60 days, whatever. It doesn't really matter, okay? Now, what you might see is this scenario is if the teams are only working on one feature at a time, okay? If you have a whip of one, I'm not saying you should, but I'm just saying this scenario, then what we're saying is these top 8 features have close to, if not 100%, probability of finishing, okay? The top 8 of by priority. And as you can see, as you get down to the list of lowest priority, you see that it's almost, at this point, you're pretty much, it's almost guaranteed that you're not going to do these features, right? As close as possible. So it's the opposite of the top green one, right? Fair enough. But what you can see is if you work in a very low WIP environment, right? In this example 1, that mathematically, your priorities, this also assumes that you don't have a bunch of dependencies, okay? Because dependencies will trump the priorities as well. But assuming you don't have dependencies, and assuming in this scenario that you're only working on one at a time, then the prioritization makes sense. Now, does the prioritization guarantee that you're going to actually make money? No. We just talked about that, right? But even with the idea that your prioritization technique is great, let's say you have the best one you invented and it's the best one in the world. Okay, fair enough. At least with this working in a whip of 1, you can deliver by the priority at a minimum, right? Now I'm going to change it to 2. Now the team has a whip of 2, okay? And similar, in fact, you might notice that I think there's one more green thing in here, actually, okay? So what it's saying is even with a whip of 2, it's not necessarily worse than 1. And one could make the case that it's better for this team. Now, you could argue that all you want, right? Because you will see that this yellow one, which was 77%, what happened to it? it went down to 23%, right? But the one below that went up to 91. So basically what I'm saying is between 1 and 2, not all that different in the results, right? I'm going to cut to the end, the big kicker here, okay? If someone comes to you and says, look, I don't understand why you're working on 2 things at a time, because I can't give you feedback if you're only working on 2 things at a time on the other features that are part of this release that are really important to me, okay? And I want to see progress on the features I care about the most. And the other stakeholders say the same thing. Fair enough. So we'll just start them all. We're going to go, and let's say over the next 3 months, we're planning 18 features. We will start working on stories for every feature. This way, when we're at our sprint reviews or whatever we're using, you can see progress. Fair enough, okay? What do you notice? I'm going to go back to the first picture.
The probability of successfully finishing nosedives into, I think, the biggest one with the biggest chance of success with 18 things currently in progress.
Yes.
I think was, what was it, 20%?
Oh, with 18 things in progress, there are some things which do have a high probability, actually.
Right, but comparatively, they're very small.
But there's a lot of other things that have way less. But one thing you might notice is priority number 1 now only has a 75% chance of finishing, okay? When priority number 1 in the low WIP scenarios was almost guaranteed as much as you can be.
Okay? Right.
The second thing is I want you to look at the greens and I want you to look at what has the highest probability on this picture and the priority of it.
Yes, some of the ones with the highest probability are 13, 14, 15,
17, 5, 3.
Yeah.
The point, this exercise of using probabilistic forecasting, which is actually what this is doing, is showing you the higher your WIP is, the less valuable your prioritization even is, basically. Because what this is saying is the higher WIP you have, the more things you work on at a time, the less you are likely to actually deliver in any type of priority order whatsoever, okay?
Right.
So there's 2 elements to this. There's the idea that we can't know the future, and the more we try to spend time prioritizing work based on the value we think it has. Now, is there value in talking about what could be valuable? Of course, there's value in doing that activity because you're getting your thoughts on paper, thinking about what we could even right size, what we should even make smaller. But to assume that you know X thing is going to make you $10,000 or $30,000, if it's not, again, some compliance, regular, normal product development, you don't know. And then on top of that, we often work in very high WIP environments where teams will start a lot of features at a time. They'll have a lot of different things, projects in flight. How about teams that are working on multiple products at a time, projects at a time? You've probably seen that too. That's an example of this picture where priority, you might as well just throw it out the window. It's pretty much meaningless when you're working that way, as well as dependencies. If this team had dependencies on other teams, I don't care how you prioritize this. The priority will be by what happens with the dependencies, actually.
So what I'm taking away from this, Troy, like the super simplified lesson is, if you don't control your WIP, you might as well do voodoo chicken waving when it comes to prioritization, because
100% correct.
It does not mean shit.
Yes, prioritization doesn't mean shit when you have if you don't control your WIP, and it also doesn't. It doesn't really mean. I mean, prioritization by value is only good to have people have a conversation to go figure out which stories or which projects or products or features we should try to break into small bets. That's really the value of it, okay? Now, I'm going to show you now how to do that with small items, like a story, and then I'm going to show you my calculator, which is doing it with features and epics. So let's do that now, and this will wrap up the podcast, really. So the small items, I should have shared that. The small item. So one way you can do this, there's more than one way, but. So what you're looking at here is a cycle time, and I'll share this picture with people, is a cycle time scatter plot. Now, I talked about this on the number 1 thing killing your delivery episode, which was about flow debt. This is also number 1 or 2. To me, right sizing and flow debt, actually funny enough, this might be the number one thing, actually. I just said the number one thing because a lot of people in the Agile space know that you're supposed to break things small, right? And because they know that, I was trying to say, well, there's this other thing that you don't know about that is like a big reason why that was a flow debt thing. But a lot of people in general don't really see the value in trying to what we call right-size things, right? And it's all about trying to place small bets. So what you're looking at here, and I know you know probably about this, but I'm sharing it. I'm going to talk as if you don't know anything about this, Jay, okay? Because for the audience, mainly, I don't know who knows what. So in this cycle time scatter plot, you basically have the cycle time, and I'll show what that means in a minute on this chart, but the amount of time something spent since we considered it started versus we considered it finished, whatever that means in our process. And then the completion date. And each one of these dots represent an item. In this example, they're user stories, okay? And you can see that this particular team has a pretty high variability of their cycle times. It's nowhere near the worst I've seen. In fact, it's not even bad compared to a lot of real teams I've seen. But in this example data, you can see that some stories they do in 15, 16 days, some stories they do in 1 to 2 days, and then there's a few outliers here and there, right? Okay, now, that's pretty typical that there's going to be outliers like that. Now, what this chart is doing is it's saying out of all of these dots, 85% of them, from a calculation perspective, so let's pretend there was 100 dots here, right? Out of 100 dots, 85 of them fall within 15 days or less, right? 95 of them fall within 22 days or less. So that's basically saying that when we bring in a user story, because these are user stories, into our system, there's a 95% chance, based on our previous data, that when it comes into our process, it's going to take 22 days or less in this example, because this is a visualization of the results of our actual process.
Right. This is past data visualized to allow you to say, oh, okay. So when you come to me and say, Troy, how long is this feature going to take? I can tell you, well, we have an 85% certainty that we're going to finish in 15 days.
Right. Which is a type of a probabilistic forecast, right?
Right.
Because you have a range, which is 22 days or less in this example, and the probability is 95%. Right? There is also a 5% probability that it won't be done in 22 days or less. That is true. Right. But what this allows you to do, number one, is it understands your risk when you're forecasting, right? So you know, by going with this, you say, well, if we were to forecast 15 days or less to finish a story, there's a 15% chance we could be wrong, right? Now I'm not using estimates. I'm not using Fibonacci roll up of estimates. Now I'm not adding estimates on top of estimates and then dividing it by an average and then forecasting and doing all of this work. I'm actually just looking at the way that the business cares about stuff, which is how long does it take to do?
And that is so I want to take a moment, Troy, to emphasize that, right?
Yes.
And we've all gotten caught in this trap where we want to think, well, estimates. Looking at this cycle time scatter plot, it doesn't matter if that one dot that took, say, 38 days. Right. Who gives a shit if we estimate it as a 1, a 2, a 5, a 20, or a 900? It doesn't matter. Right. It took 38 days. Right. So exactly. Literally throw your estimates out the window. Use your past performance and behavior to create because cycle time. Ben Now Young, I love Ben. Ben always says cycle time isn't a number; it's a shape. Yes. Good. Thank you, Ben. Distribution, right? This is the shape, what you're looking at here. The shape is a pretty significant amount and nowhere near that bad, to be honest with you, of variability in these cycle times, right? Right. That's one thing you're looking at. So why does this team have some stories that are done in 1 to 2 days? Why do they have a bunch of other stories that are done in 13 to 16 days, right, as a range, right? There could be a ton of reasons for that. One of them is what the previous episode was about, which is flow debt, which is they started these items, they stopped working on them to work on these items to get them done, and now they've incurred a cycle time debt, which they're going to have to be paid back, and that debt shows up on this chart in the form of variability. That's the whole concept of flow debt, right? Right. The other part of this is and I want to pause on that, Troy, for people in the odd chance that someone hasn't heard the last episode. Yes. We explain flow debt. So flow debt is the mathematical equivalent of robbing Peter to pay Paul, right?
Yes.
So I am stopping work on your task, your feature, because I'm going to go work on Colleen's feature. So I'm going to accelerate Colleen's feature, and I'm going to get 4 days off on it. However, that 4 days needs to be paid back into the system, which then can add to yours. Or if I stop somebody else's to now accelerate yours, you're carrying that burden forward, and you need to be cognizant of it.
That is 100% correct, right? So there's three types of borrowers, right? There's hedge borrowers, there's speculative borrowers, and there's Ponzi borrowers, right? So the hedge borrowers are basically in finance, right? Are the people who are going to pay back everything they borrowed and the interest, right? They're the people you can count on, right? The speculative borrowers are the people who just only pay back the interest for the most part, right? But they're not like borrowing. The Ponzi borrowers are the people that borrow to pay back the interest, right? They consistently borrow, okay?
Yeah.
And what happens is that our world, a lot of people are running a Ponzi scheme where they will consistently just keep borrowing from items constantly, and they have to pay it back later. And that actually looks like a much worse version of this picture in reality. Okay, you will see very high variability. Right?
Yeah, you get huge variability, and your cycle time just keeps going up and up and up and up because you borrowed so much that you've made off. Here we go. You've made off your cycle time.
Right. There you go. That's a good one. And there's many reasons for that, for reasons why that happens. Some of the core reasons, though, are expedite lanes, classes of service. So a lot of people will tell you that you should have classes of service. You can have classes of service, but the argument I'm making is it's probably not the best idea. And if you do have them, you should have a very, very good reason why. For example, if production is down and you want to call that a class of service, by all means, call it a class of service. Understanding that, okay, for this one specific type of incident, we will just incur flow debt because we understand that that's a valid reason to do so, right? That is not the same thing as daily incurring flow debt because of whatever. Because if somebody wants their thing tomorrow, we just keep reprioritizing things after we already started it. Basically.
Yeah, the best. Shout out to Dan McCanty for making the best argument against classes of service ever, using a real life example. Anybody who travels for work or travels consistently that does not have clear TSA pre-check, global entry, all that bullshit.
Yeah.
You know how aggravated you get when you fly through that small airport and you're waiting in line to go to the TSA, and then some jabroni shows up with their pre-check, clear, global entry, and this poor agent has to stop what they're doing and turn and service this expedite person. You know how pissed off you get when you now have to wait? Your cycle time has now gone up because the expedite class of service came through. If that isn't the argument to never do expedite lanes in your process, I don't know what is.
All right.
Put yourself in the shoes of the guy having to wait.
So don't use expedited lanes. You don't need an expedite lane to expedite something.
Okay? There you go.
So you don't need an actual lane to do it. You can certainly just expedite something if you really need to. Okay, so just throw that out. Try not to use class of service unless you have a very, very specific reason why you need a special class of service. That's another one. So that's a couple things. The other things are not actively addressing blockers, letting them sit, right? That's a perfect example. If you go to the Wikipedia page for Kanban, it will show you a blocker column. That's one of the worst ideas you can possibly do. Okay, so don't do that. So Wikipedia is bullshit. So that's one thing about Kanban. If you go ask ChatGPT about Kanban or Agile, it's going to be wrong too. So what I'm saying is the landscape of what we think about in Agile is just based off of I don't know where it comes from, but it's not based off the original people who created this stuff, like Deming, Stewart, Dr. Little, and even Don Reinerson, who's like a thought leader, in the last 30 years in this space, right? So it's not based off of any of those people. So what we're trying to do is say, let's base it off of the original things that came first, right? The original guys and girls and ladies who were just inventing this stuff in the first place, right? What can we learn from them? So that's what we're doing. So I'm going to show you now. Now I talked about, so how can you right size something let's just cover this for 1 second. How can you right size something on this picture, right? Well, one way you could do it is, let's say for some reason you were satisfied with these numbers. Okay, in that case, 15 days or less with an 80. So you can say with an 85% certainty that you could get an item done in 15 days or less. Let's say that was good in your world for whatever reason, okay? Now, you could look at an item and have a conversation as a team. Now, the range of these items, you can see there's a wide range, 1 to 15, right? Does this item fit, once we talked about it, within 15 days or less? Because that is, if we're happy with that number, that is basically our expectation of our forecast. And now I'm picking 85% just as a random number, but that's what a lot of people will choose. So the point is, does it now, developers, whoever is a developer yourself, or if you've worked with them, one or the other, how often do they like really using story points and then getting those story points rolled up and then using that for forecast and using velocity metrics? Let's be honest, they hate this shit, right?
They hate it.
Why would we even, what we try to do, we as the Agile community, is try to get them to not think about things in terms of time. And in their head, and if you've ever been a developer, you're just equating it anyway in terms of time. And then you're just giving an arbitrary number. Oh, it's a 3, right? Like in my head, a 3 means a week or whatever the case, right? That's pretty much how they're thinking anyway. So why not use the language that the business uses, the language that the developers want to use? Don't use metrics like velocity and story points and all this crap that at best were once an idea that was supposedly trying to address a problem, right? But that has gone so off the rails in the industry that has just become extremely harmful. Just use the way the business thinks about it and the way the people doing the work think about it, and use probabilities. Understand the associated level of risk when you're coming up with how big something is. The second caveat to this is, let's say you're not happy with this 15 days or less, right? Let's say you think, you know what, our 85th percentile, when we bring an item in, we should be able to forecast it 8 days or less, right? 7 days or less, whatever the case is. You can simply use that as, does this thing fit within 8 days or less? Really simple. Does that mean that the size is 8 days? No, that means that the longest compared to the other items that took 8 days, 10 days, whatever, the longest that we will allow it to be based on this is 8 days. That's like the maximum size, not the actual size. If we can do it in 1 day, that means it's right size. 2 days, it means it's right size, but it can be no bigger than this 8-day kind of range. And you can talk about that as a team. One of the other things you can do if your team is used to using planning poker is you can use these type of cards to shift them away from the traditional planning poker. And basically say, look, if we want to get to what I was just showing you and you like using planning poker, fair enough. Maybe it works in your context for having a good conversation. Fair enough. So you can use these cards. There's one card that has a 1. There's another card that says it's too freaking big. And the other card says I have no freaking clue. And you just have these conversations over and over again, right? And you just try to get everyone to vote the 1 if we can get alignment on that. Otherwise, it's too big. Keep splitting it. And then you can reference that with your, like what that 1 means. Is that in that 8 and under range, right? All these items. Yes, perfect. Now when we come in, we'll just talk about it in terms of our cycle. Don't even need to use the cards anymore. So that's kind of one technique you can do. So what about multiple items, right? Now, multiple items gets a little tricky, okay? When you talk about features, epics, projects, products, all this kind of stuff. So how we forecast for multiple items in Pro Kanban is we use something. Now, we can have a whole episode on this. I'm not going to do this right now, but I will just walk you through this one picture. And basically, you can say, when can a certain amount of items be done? Or you can say, how many items can we get done by a certain date, right? So you can use this. This is another type of probabilistic forecast. And this is the one that's used in machine learning. It's used in finance. It's used in weather forecasting. They're using different types of a Monte Carlo method. So again, now no history. We could do a whole episode on Monte Carlo. But what I want to show you is for multiple items, because it's relative to breaking down multiple items. If you are breaking things down, right, to placing those small bets, you're breaking your features in smaller sizes, right? Your forecast will become more accurate. And I have, and better actually, and I have some data that's going to show you that right now. So what you're looking at here is a Monte Carlo simulation of inputting how many items, so today's May 20th, can we get done by June 19th if you're this team? Give an example. Okay. And remember I told you about running the roulette wheel, applying the law of large numbers. So this little button over here that says more will run as many simulations. So in this example, it's running 1 million simulations. And what it's doing is It's taking this team's actual throughput metrics of what this team actually did in this example, 6 months, their actual throughput, which is the result of their process, if you think about it, and the process around them.
Yep.
And using that actual data and then forecasting based off of probabilities, running random simulations on their data, in this case, 1 million. And it's saying out of 1 million simulations, just like we did in the Gambler's Ruin game, 850,000 of them, this team was able to do at least 16 items by June 19th, okay? And then 950,000 of them, they were able to do 12, 700,000, they were able to do at least 18, and that is in the form of percentiles, as you can see, 75%, 85%. So now simply, we can just have a conversation about risk. So it's, for example, if we had, we can look at this and say, well, there's an 85% certainty we can do at least 16 items. The product owner wants to do 22 items. That's kind of what's in the backlog for the next month, right, in the release. In that case, well, what's the probability of completing at least 22 items? Well, it's 48%, right? What are we going to do about it? The reason why this is called actionable agile is because this conversation is now actionable. I'm not taking an average of relative estimates, using that to forecast, and then when we're wrong, saying you need to estimate better, okay? Because we're going to be wrong all the time with that approach. Plans and forecasts based on averages fail on average mathematically. And there's a book called The Flaw of Averages, which goes through the math behind that. Anyway, long story short, you could simply have a conversation, well, should we plan at least 16 items, knowing that there's a 15% risk that we won't hit it? Should we do a little bit of a Moscow, where the top 95% is our most important, what we think, that's the prioritization piece, right? We can go down that percentile. There's many ways to have this conversation, but really what it's going to do is help you and your people be realistic about forecasting with an understanding of risk. Okay, again, a whole episode could be done on this. Let's get to the calculator so we can go. So what I built was, with the help, not by myself, of Pratik Singh again, because in one of our trainings we have for applied flow metrics for Scrum, there's a slide in that talks about feature right sizing. Or is it that one, or is it? No, it's in the the portfolio scaling Kanban class. Regardless, there's a slide in there that talks about feature right sizing. And I said, well, it would be nice if my students had a calculator, not just a slide, right? So that's what, and I want it myself. So I want this exact calculator is what I'm saying. So I just built the calculator for the most part. So the way this works is, this is the top left picture is what I'm going to zoom in. This top left one is basically what the slide is. And then I'm going to talk about what we built, what I ended up building here. And a friend of mine, Warren, helped me with some of the Excel, getting some of the visuals in Excel correct. So this top left one is, I can see all of the features that were delivered in my process, right? I can see that 85% of them have 18 stories or less. Okay, so that's one thing that I can see, right? So I can say with an 85% certainty that we bring a feature in, it's an 85% probability that it will have 18 stories or less based on our previous way of working, right? 50% done 13.5, right? So you could right size. One way of right sizing is looking at the features delivered, how many stories they had or PBIs they had, whatever you're using, and use this data to think about what should be the maximum amount of the actual size that's right for us. So what I did was I said, well, I want to see what the feature cycle times were relative to the size, right? So now this right picture shows you feature cycle time and percentiles. So what this is showing you is that 85% of our features are delivered in 72 days or less, right? And 85% of the features have 18 stories or less. So now the big reveal is I put those two things together. And basically I can see on the x-axis the number of stories that were contained in the features. And the y-axis is the feature cycle time percentiles. Right. So what this will show me is that if you just look at this cluster here, right? I can see that I want the lower percentile, the better for cycle time is what you're seeing in this example, right? Mm-hmm. So in order to be in the top 50th is better than the top 85th, if that makes sense, right? Because it's this, we want lower cycle times, right? So in the top 50th percentile, I can now see on the x-axis how many stories were in those features, right? In the features that were delivered. And so for these features that are in the top 50th, none of them were, except one outlier, were bigger than 14 stories, right?
Right. So this is using data to generate the heuristic, which is telling me rule of thumb going forward. If we want to minimize cycle time and maximize value delivery, none of our features should have more than, looking at this data, it looks like about 13 stories.
Yes. So as we're writing and refining our stories, right? If we're writing a bunch of acceptance criteria, features, I'm sorry. If we're writing a bunch of acceptance criteria for features, and if you've ever written acceptance criteria for features, you know that they usually, in one way or another, turn into stories. You can start to see by the amount of acceptance criteria, really quick, a conversation with the team. Are we getting over this number or not? Without even needing to write every story, actually. Okay. You can just look at the acceptance criteria. You can get them to think because they know what they're doing. They know how to write stories. They've been doing it most likely, right? So then when you do start to write your stories, you can check yourself against the data. So if we want to be in this top 50th percentile, because if you can start getting things into that top 50 percentile more often, guess what's going to happen to your percentiles? They're going to come down. Yeah. Right. So your feature cycle times are going to be faster, right?
Right. So based upon what
is going to be lower
now, Troy,
right.
51 and a half days, right?
Right.
So if I say 51 and a half days at, say, 13 stories,
yes,
I can eventually drop that cycle time. So maybe I've come to learn that my team sweet spot is we can get 50% certainty at, I don't know, 30 days if we only have 7 stories, right? Because over time, you're gonna constrain in the right way, right?
Yes.
Constraint is a bad thing. You're going to force yourself to shift the cycle time down by shifting the amount of bets that you're taking that are of smaller size,
right?
As opposed to blowing it up and
correct. And if you look at this data point, which is 6 stories, right? It's in the top 18th percentile. Right? So just because we're saying 14 stories, we're not saying your features should be 14 stories. We're saying your features should be no more than 14 stories, right? And you can look at, were the features delivered in this 14 story range, were they valuable? You can start to look at your actual value data, right? You start to do an inspection on that. Oh yeah, well, there's no way we could have known ahead of time whether exactly it was going to be valuable, right? But they were sized appropriately to be valuable. That was what I'm saying, is the bet size has to be sized appropriately to get some kind of value, right? If the case is yes, especially even for these smaller items, so the faster ones, if you can say, yeah, these actually turned out to be pretty valuable, or it could have been, right? It's just that maybe we're wrong about an assumption. Then maybe we start to bring this down and we start to split our features based off of that data. The point is, without this type of analysis about feature sizing and looking at your cycle times, if you only look at your estimates, right? If you only look at Fibonacci, and poor Fibonacci, he's probably rolling over his grave right now about how this shit is used. So anyway, so that's just so why not just use actual real data that people care about? How fast do things get done? What is the rate that things get done? That's your throughput, right? How fast do they get done? How old is something and it's not yet done? That's the work item age construct, right? Because how old it is right now is the leading indicator for your future cycle times, right? And so work item aging, and this is the last thing I'm going to say because this could be a whole nother topic, should be. Work item aging is the number one way of controlling WIP. It is actually not WIP limits. That's kind of, if you come to any of the Pro Kanban classes, you will learn how WIP limits are something good to do, but they are not the end all be all. When people think about Kanban and they think about flow, the first thing they think about is WIP limits. And then anybody's going to sell you a magic pill that tells you exactly what your WIP limit should be is just selling you.
It's work item aging, it's queue depth, it's all those things that it's not.
Right. So think about this. Think about this. What's the easiest 2 ways to control the work item age? Now, remember, for those listening, the work item age is a leading indicator for your cycle times. And it's also a leading indicator for your throughput, how much stuff you can get done. Because if you just keep allowing things to age, nothing's going to get done, right? So therefore, if you care about throughput, which a lot of people care about, and you care about cycle time, which a lot of people care about, right? Even the DORA metrics, frequency of deployment, that's a throughput metric, for example, right? All of that, okay, fair enough. So the number one way of using a leading indicator metric is work item age. So the two easiest ways of controlling work item age, the two easiest ways, number one, if you've started something, finish it. That will control the item age, right? Number two, don't start things unless you have the capacity to actually do it, right?
Yep.
It can't age if you don't start it, right? That's like that, that's like that meme where, there's a dude with this, I forget the meme. I'll try to find a picture. But anyway, it can't.
All I heard, Troy, was don't start no shit, there would be no shit. That's all I heard.
Pretty much, right? There's other things you can do to control work item age, but those are the easiest two things to do. If you finished it, focusing on starting it, right? And that's the whole flow depth concept. And don't start things unless you actually have the capacity to do it. Don't start things just because someone's telling you or because you have 10 developers on your team. Therefore, you should start exactly 10 items at a time.
Right.
There's like all of these reasons how you can control work item age, and they're all a leading indicator to this type of thinking. Another way you could control work item age, by the way, is by breaking things down into small bets.
Smaller and smaller pieces. Because
what will happen is some people tell you, oh, well, once it started we can't split it. That's total bullshit. Right. If you started something and it's aging and you realize it's aging because it's too big, why would you not split it? It doesn't make any sense. And I understand the reason why people say that is because of stupid story points. Because what they'll do is they will look at the story point, right? And they will say, well, if I split it right now, I'm not going to get credit for this thing or whatever. They will basically say, well, how I might get credit for this story, but I'm not going to now get credit for this story. So therefore, my velocity metrics are going to look bad. All this crap, right? It's just like...
And your customer is sitting there at the end of this process going, I don't give a shit about your velocity, your points, how you split it. I need this thing.
Right.
So maybe Troy, maybe one of the things we just uncovered here is the problem, the central problem that we're all fighting against is the lack of centering around what is important. What is important is making the customer happy. Anything aside from making the customer happy is ungats. It's not worth shit.
And
so if I worry about that,
and how we don't even, there's two types of making the customer happy. There's the customer in the sense of someone internally at your company is waiting for something, right? Like a stakeholder, a business owner or something. That's one type. But the actual real customer for external facing products is the people paying you to do something.
Who's going to pay
salary, right? Yes. And so the only way that we can know if they're happy is by if they're willing to pay for something and keep paying for it, right?
And the only way we're going to know, Troy, if they're willing to pay for it and be happy paying for it, is to get the shit in production.
Yes. And in order to do that, we have to break things down small and take small bets because we could be wrong about whether we think they will pay for it or whether we'll think they will even use it, even if it's a freemium model, right? So basically, this all comes down to focus on placing as small bets as possible all the time. And then any type of process improvements you make, all of this flow stuff, all of this stuff is going to make a bigger impact than if you didn't break things down small, play small bets, right? And that's just the gist. That's a long way of saying. We took a very long way of getting to that point, but I wanted to show some pictures, some charts, and hopefully if you're a geek.
Well, there's math behind this. Yeah. Right. And there's math. So someone like me who learns via the math, which is why I started asking you those questions about, okay, well, why probabilistically does with a smaller bet, you can't just give and Troy, I'm gonna end us with a statement, a bold statement. I think the problem we've encountered in our agile world, right? And we're a part of it. So we're turning the mirror on ourselves.
Right.
The problem, and you asked, like, how did we get so far from the truth? Or from where we really should be, which is where we are. I think it came down to us rushing to the conclusion without doing the work to understand why that conclusion is there.
Yes.
So you walked us through the math to explain why you did this. However, some enterprising salesman could listen to the last 3 minutes of this podcast, make a couple of bullets, turn it around as a book and sell it, and people will, and then just the way the game of telephone works, eventually it's going to get totally butchered.
Right.
And it's, again, you need to do the work to understand where the conclusion comes from.
Right. And so people may ask, well, how do you prioritize work, or how would you coach it? Things like that, right? What I do is I think, okay, I don't mind. In fact, I don't mind having a conversation about business value, risk reduction, opportunity. To me, those are good things to have a conversation about with people, right? Have the conversation, right? Just say, okay, let's talk about what we think could be one way or the other. We're not going to assume that we're right. We're not going to assume quantifiably that we're right about this, right? But we're going to have the conversation. That's enough to figure out which items should we start breaking down small to start placing our small bets. That's pretty much it. You can use any framework you want to do that. You don't have to use business value, risk reduction, opportunity, but you can use any type of value metrics you want. You can do whatever you want. Like, just to me, that's a good enough one to have the conversation, really. So it's, there's good ideas out there, right? It's just that the implementation, a lot of these things kind of get, I don't know, misused or whatever, right? Ron Jeffries, and I said the last thing, this is the last thing. Ron Jeffries, who says he feels sorry, he feels bad, basically, about inventing story points and in turn velocity, which comes from story points. And he has a bunch of quotes about that, actually. And what I do, a lot of times when I do it like an intro to probabilistic forecasting, I will open up with a slide of a bunch of quotes from Ron Jeffries about story points and basically try to make the case that even the person that invented this said he wished he didn't do it. Right?
Wish he didn't do it, yeah. So
if that isn't enough, if you don't listen to us, listen to the person who invented it. You can Google Ron Jeffries and story points, and you can see all his, or whatever search engine you want to use, and see all of his quotes about that. So thank you, Jay, for having this long conversation, but I had fun. So hopefully people.
No, this was really insightful. I would challenge all of our listeners, like, look into your course, and we'll throw a link in the show notes.
Right.
Go back and read the little paper around Little's Law.
Yeah.
Pick up Don Reinertson's book, The Principles of Product Development Flow, second edition. 99% of the shit that we've talked about comes from, at some way, shape, or form, there. Monte Carlo simulation. You look at Troy McGinnis's work. Dan McCanty has a ton of work on this. Long story short is to say, there's a ton of knowledge out there that has been lost and butchered by the game of telephone. And if you really want to excel, not only excel in your coaching, your scrum mastering, your product ownership, product management, but also help your organization actually deliver the value that it can, this is the kind of stuff you got to dig in.
Beautiful. And we have this is going to be a plug at the end. So we're going to link some books that you can read. Everything's free. The resources are free, right? If you want to take like a class on this, you can go to procombine.org. They have classes on these topics, certification classes that you don't have to renew one time and you're done. So that's always nice, right? And they're not even that expensive relatively. So you can go, I'm a trainer. There's a bunch of other trainers. You don't have to take my class by all means. Even Pratik and Dan sometimes teach in-person classes. So go take one of theirs if you want. So basically, but take someone's class if you want like an instructor-led way of doing a Q&A about this, because some of it's not that easy to just understand intuitively, because we typically don't think about it in this way, especially the probabilistic part. So anyway, we also have an Agile Uprising Discord. If you want to talk to me on there, if you want to talk to Jay or any of the other Agile Uprising members, you have questions, we can answer your questions potentially, or we can point you to resources for further reading. So yeah, we'll link the Discord and the show notes.
Awesome. And like Troy said, if this is a conversation that you really enjoyed and you want to hear more of it, the only way we know is if you let us know via feedback. So hop in the Discord channel, right? Hop in Discord, send us an email. So you can contact us a bazillion ways from Sunday, right? Hell, find Troy and I on LinkedIn, send us a message. But these are the kind of things that we would do more of if we knew people liked them. So if you do like this and you did get something out of it, please let us know, and we'll do more of that. Troy, I know we're over an hour, so I'm just going to get us out of here by saying, until next time, this is the Agile Uprising podcast signing out. And Jay, I'm going to give a teaser. Next episode, I think, should be why we're all wrong about Little's Law. Cool? Okay. Yes.
All right, let's do it. Okay. All right. Thank you, everybody.
It's Jeep 4x4 season. Make your next adventure epic and hurry in now for great deals. And now, well-qualified lessees get a low-mileage lease on the 2023 Jeep Grand Cherokee 4xe for $389 a month for 24 months with $5,399 due at signing. Tax, title, license extra. No security deposit required. Call 1-888-925-JEEP for details. Requires dealer contribution, a lease request, or capital. Extra charge for miles over 20,000. Residency restrictions apply. Take delivery by 5/31/23. Jeep is a registered trademark.